wave optics. Before going to study the wave optics, we have to know the few definitions related to related to wave optics. First one is the light. Light is a part of electromagnetic radiation which is identified by human eye and which have wavelength in between the 400 nanometer to 700 nanometers. And we can also call UV color to red color is also called light. And light travel with the velocity of c is equal to 3 into 10 power 8 meters per second. And next one is the optics. Optics is nothing but the study of propagation, properties, effects of light in a medium and its applications. And optical instruments is also called optics. And effects of light, here geometrical optics, which deals the reflection, refraction and total internal reflection. And another one is the wave optics. It deals the interference, diffraction and polarization. We are going to study wave optics. Coming to the interference, we have following topics which are related to interference. First one is the principle of superposition and coherent waves, interference of light, condition for sustained interference, interference in thin films due to the reflected light, Newton's rings, determination of wavelength by using the Newton rings method, engineering applications of interference. Principle of superposition state that when two or more waves meet at a point, then the resultant wave displacement is equal to the algebraic sum of the displacement of each wave. For example, here we can see a wave pulse travel from left to right and another wave pulse travel from right to left, and they meet at a point and we will get the resultant wave. The displacement of resultant wave is equal to the algebraic sum of the displacement of each waves. For example, here see wave 1 and wave 2 are in the same phase and they meet, and resultant wave displacement is equal to the algebraic sum of the individual wave displacement. For example, resultant wave displacement is 2x is equal to the x plus x, which are displacements of wave 1 and wave 2. If two waves are in out of phase, then resultant wave displacement is equal to the x1 plus minus x, then we will get the 0. Next one is the coherent source. The source said to be coherent if they emit light waves of the same frequency, nearly same amplitude and are always in the same phase with each other, then the two sources are called coherent sources, which means the two sources must emit the radiation of the same wavelength or same color. In practice, it is not possible to get the independent two sources which are coherent, but two virtual sources from one single source can act as a coherent sources. We can get coherent source. We have two different methods. One is the division of wavefront, another one is the division of amplitude. In case of division of wavefront, waves from two sources are formed from a single source which act as a coherent sources. Another one is the division of amplitude, in which waves from two sources are formed from a single source due to the reflection or refraction, in which one of the source is real, another one is the virtual source. Interference. The phenomenon of interference of light has proved the validity of the wave theory of light. Thomas Young successfully demonstrated on his experiments on interference of light in 1982. Definition of the interference. Interference is a physical effect of light to obtain modified or variation of intensity like alternate bright and dark intensity by superposition of two or more number of coherent light waves at a point in a medium is called interference. For example, redistribution of light energy. We can observe the interference in our daily life also. For example, rainbow, colors on soap bubble, colors on surface of oil film, etc. Conditions for sustainable interference. These are the conditions. First one is the light source must be monochromatic, and another one is the light interfering waves should be coherent, which means same frequency with a constant phase difference. Another one is the wave should travel in the same plane with the same direction, and amplitudes of wave should be nearly equal to get good contrast in fringes and appear distantly, and two waves must have the same state of polarization to get fringes of maximum contrast. And final one is the path difference should not be very long compared to the wavelength of the sources. Types of interference. There is the two types of interference. One is the constructive interference and another one is the destructive interference. Constructive interference due to the constructive superposition of two or more waves, and the destructive interference is due to the destructive superposition of two or more waves. In this figure we can see, for example, example for the constructive interference. Here two waves are in the same phase, then we will get the resultant wave which is due to the constructive superposition of these two waves. And another example, these two waves are in out of phase, which is 180-degree phase difference, then we will get the destructive interference. For example, this is another example for constructive and destructive interference. Here two waves are in the same phase, wave 1 and wave 2 are in the same phase, then we will get the resulting waveform due to the superposition of wave 1 and wave 2. And another example, these two waves are in the out of phase with 180 degrees, then we will get the resultant wave like this. This is the example for destructive interference, and this is the example for constructive interference. These are the conditions for constructive interference. Path difference should be 0, lambda, 2 lambda or n lambda, which means the path difference delta should be equal to the n lambda, and phase difference delta equal to 0, 2 pi, 4 pi, 6 pi, and we can say also 2n pi will be the path difference. And the intensity of interference due to the constructive I is equal to 4a square cos square into delta by 2. Delta is the phase difference. And condition for bright fringe intensity I is equal to 4a square. Coming to the destructive interference conditions, path difference delta is equal to lambda by 2, 3 lambda by 2, 5 lambda by 2, equal to the delta, which means path difference delta is equal to 2n plus 1 lambda by 2, and phase difference delta is equal to 2n plus 1 pi, and dark fringe intensity I is equal to 0 in case of destructive interference. This is the intensity redistribution in interference. Then we can say we can see the alternative bright and dark fringes. For example, this is the dark fringe, bright fringe, and we will get the dark one, bright, dark, bright and dark. These are the phase differences in the spectrum.